In this video, I'm going to show you how to find the derivative of any logarithmic function, no matter the base. If you haven't watched the video on how to find the derivative of exponential functions, go back and watch that first. We're going to use that information. So the information we proved last time was basically that y is equal to e to the x has the derivative of e to the x, or e to the x is its own derivative, which is a little bit weird, but is very, very true. Whenever we come to a problem, a new problem, with things we can't do, we rearrange and put it into terms we do understand, other things we know. So my hint is, okay, I don't know how to find the derivative of the natural log of x. That's our goal to show you. But I can rearrange to get, well, no natural log of x. So how do I get rid of natural log of x? That's, or the natural log operation, that's the inverse operation of e to a power. So I can rewrite both sides of my equation as exponents to the base e, which would mean e to the power y is simply equal to x. And you might think, well, what did you do there? What I did is I rearranged into things I already know. The derivative of x with respect to x is very easy. That's 1. And if you knew what we proved last time, the derivative of e to the x is e to the x, we can take the derivative of e to anything, like e to the y. So the derivative of e to a power is e to a power. Our power is y, which is some function, in fact, the natural log of x. And so we have to use the chain rule, or implicit differentiation. Multiply by the derivative of y, so I'll just use the notation dy dx. Well, I knew my derivative was going to look like dy dx, so I'll divide both sides of my equation by e to the y. Uh-oh, what the heck is that? I didn't really expect the derivative of natural log of x to have a y in it, so let's go back and look. E to the y is equal to x, so the derivative of natural log of x is actually 1 over x. Okay, the derivative of 2 to the power x. Let's think for a moment. If I was given e to the power x, I can do that derivative easily. That's e to the power x. We've proven that. We'll keep using that. So I'm thinking the derivative of 2 to the power x is something like 2 to the power x, but I don't really know, so maybe we can rearrange. Well, what do I know? Well, a logarithm is a function that allows you to rearrange exponents. Specifically, in this case, let's see, natural log of 2 to the power x allows me to take that exponent x and make it a coefficient on the natural logarithm. So natural log of y is equal to x multiplied by the natural log of 2. One thing you're going to have to keep in mind here is what sort of thing this natural log of 2 is. You may not know exactly what number, but you should know that natural log of 2 is some constant. It's a number like 2 or 3 or 5. In fact, it's something like 0.693. Who cares? So that just means we're going to be on the right-hand side of the equal sign. We're going to be taking the derivative of some constant, natural log of 2, times x. That has a derivative of just 1. Well, sorry, that's not true. X has a derivative of 1, multiplied by the natural log of 2 would just give us natural log of 2. I'll put the 1 in there. What's the derivative of natural log of y? Well, we came up with the derivative of natural log of x is 1 over x, so the derivative of natural log of y is 1 over y. Except for y is some other function, so the chain rule applies. We'll multiply by the derivative of y. And so let's see, what do we have? Multiply both sides by y, so we'll have y multiplied by the natural log of 2. And resubstitute. Look back up top, what is y equal to? 2 to the x. So the derivative of 2 to the power x is 2 to the power x times the natural log of 2. Well, the natural log of the base 2. We showed the derivative of e to the power x and 2 to the power x, but let's make sure that's a rule. We're actually going to just go through and do the exact same work we did for the derivative of 2 to the power x, except we're going to leave that base, instead of 2, we'll leave that base as a, which means any number that's allowed to be a base. So the first thing I want to do is rearrange to get rid of that exponent x. It's bothering me. So natural log of y is equal to natural log of a to the power x. The natural log, or any log, allows me to move that x, the exponent on a, to be a coefficient. Now you might be wondering, why did I use natural log? Natural log is the easiest logarithm to work with in calculus. We had that the derivative of natural log of x is 1 over x. I don't know how to find the derivative of log base 10 of x or something like that yet. We're going to get to that soon. Well, now we've rearranged y is equal to a to the power x into things we do know the derivative of. The derivative of x is 1, and natural log of a is a constant, since a is a constant. So maybe we're doing the derivative of 5 to the power x. Maybe we're doing the derivative of 10 to the power x. I don't know. It doesn't matter. We're doing the derivative kind of all of those. If a was 5, natural log of a is some number. If a is 10, natural log of a is some number. So either way, the derivative of x times some number is 1 times that number. Just like the derivative of 5x is 5, or the derivative of 9x is 9. So the derivative of x times the natural log of a is 1 times the natural log of a. What's the derivative of the left-hand side? Natural log of y with respect to x. That would be 1 over y, chain rule, times the derivative of y. Once we solve for y prime, we're going to get y natural log of a on the right-hand side, but we don't want to keep the y. We'll go back to the very first line. Y is equal to a to the x. And so the derivative of a to the x is a to the x natural log of a. The first year I taught calculus, my students, they had already taken another calculus class. They gave me a trick, and that is almost everyone remembers that the derivative of e to the x is e to the x. But on a test or a quiz or something, when you get y is equal to 3 to the x, usually you'll remember, hey, that's something like 3 to the x, but it's probably not just 3 to the x. On this page, you're probably saying, well, that's 3 to the power x, natural log of 3, and you're right. Now, why do people forget? Sorry. The derivative is 3 to the power x, natural log of 3. Okay, why do people forget? Because e to the x is a super common function in calculus, and 2 to the power x or 5 to the power x is not. So the trick they told me is when you say, hey, what's the derivative of e to the x? You don't simply say e to the x. The derivative of e to the x is e to the x natural log of e. If you said that every time, then the derivative of 3 to the x is 3 to the x natural log of 3. The derivative of 5 to the power x is 5 to the power x natural log of 5. You might be thinking, well, you didn't prove that the derivative of e to the x is e to the x natural log of e. Well, I did. Remember, a can be any constant, and e is a constant. And don't forget, natural log of e is 1. All right. So how are we going to find the derivative of log base 2 of x? I'm sure you're reading my hint. We're going to get rid of the log base 2. Now, you have a couple of options. I'll do them both. You could rewrite as 2 to the y is equal to x. These two equations mean the same thing. But we could also use a change of base formula and rewrite log base 2 as the natural log of x divided by the natural log of 2. If you don't remember that one, go back and check out your Algebra 2 work. Which one do you want to do first? The left-hand side? Okay. What's the derivative of 2 to the power y? Being that y is some function. Well, the derivative of 2 to a power is 2 to that same power, natural log of 2. Our power is the function y, which has a rate of change, dy dx, or multiply by the derivative of y, whatever you want to say. The derivative of x is 1. Let's rearrange. dy over dx, the derivative of log base 2 of x is 1 over 2 to the power y, natural log of 2. Although we're not going to use that version. Can you find 2 to the power y in your work? Which means the derivative of log base 2 of x is 1 over x natural log of 2, also in the denominator. Oh my gosh, I hope we get the same thing when we take the derivative of the other version, natural log of x over the natural log of 2. Now don't forget, natural log of 2 is a constant multiplier. So you can think of this as 1 over natural log of 2. Just pretend that's like 1/2. We get to ignore that. Multiplied by the natural log of x. And so the derivative of a constant times something is that constant times the derivative of that something. Derivative of natural log of x is 1 over x. Okay, there we go. 2 good ways to go, both based on things we already know. So I suppose you could do this proof 2 different ways as well. I guess I'll do this 2 ways. So on the right-hand side, we'll do what we just did, rewrite log base a of x, and we're thinking, okay, well that a better be a base we're allowed to use. You know, some positive number and hopefully not 1. Use the change of base formula, so natural log of x divided by the natural log of a. Natural log of a is a constant, so taking the derivative of that, we get to ignore. So that's going to be natural log of a in the denominator, and the derivative of natural log of x is 1 over x. I think that was the easy way to go. Let's see what the other way looks like. The other way means we're going to rewrite a to the power y is equal to x. And the derivative of a to the power y is a to the power natural log of the base a. The exponent is y, so we need the chain rule, multiply by the derivative of y. The derivative of x is 1. Rearrange dy dx is equal to 1 over a to the y, natural log of a, and we don't like that a to the y, so we'll replace a to the y with x. I'm going to keep going through some examples here instead of having those separate. So what rules are we thinking? If y is the natural log of x, then the derivative of that would be 1 over x. We're going to keep that in mind. That's not part of my work. I'm just thinking that, but it's hard to see what I'm thinking without me writing. Okay, there's me thinking. All right, what are we going to take the derivative of first? This outermost natural log. The derivative of natural log of something is 1 over that something. Okay? And so, what goes down there? Natural log of 2x cubed. That input was a function, so we need to use the chain rule. So the next thing we're taking the derivative of is this natural log, that input, or maybe this natural log. And natural log has a derivative of 1 over the input. This input is 2x cubed. Hopefully you're guessing. Chain rule multiplied by 6x squared, not 3x squared, multiplied by 6x squared. Let's rearrange 6x squared over 2x cubed times natural log of 2x cubed. What rules are we going to need here? Well, you might be thinking the derivative of e to the x is e to the x natural log of e. And you might also be thinking that the derivative of a to the power x, or any allowable base, is going to be a to that same power natural log of base a. And again, this isn't work I'd write off to the side, but it's hard for me to explain everything out loud and have you follow along well. So just pretend that's me thinking. Oh no, what's the outermost function on 3x multiplied by 2 to the power 5x? That's a product of two functions. And the derivative of a product of two functions is the first function, so 3x multiplied by the derivative of the second function. I'm going to come back to that. I know that's going to be the complicated part. Plus the second function, which is going to be 2 to the power 5x, multiplied by the derivative of the first function. So we're multiplying by 3. Okay, what goes in this blank? The derivative of 2 to the power 5x. That's going to be 2 to the power natural log of the base. And the exponent, the input, or something like that, is 5x, which has a rate of change of 5. I suppose I could simplify, but I don't want to. We're really worried about using these rules. We can work on simplification another time. Okay, do you know the rules you need? Well, with the x squared in there, you're going to need the power rule. You're going to need the derivative of e to the x is e to the x. And you're definitely going to need the product rule. So the derivative of y with respect to x, the derivative of a product of two functions is the first function times the derivative of the second function plus the second function times the derivative of the first. All right, so now I'm just going to go back and fill in the derivative of e to the x squared. The derivative of e to a power is e to that same power. Our power is x squared, which has a derivative, a rate of change of 2x. Well, if you want a challenge, here you go. You are going to need a lot of rules. Let's name them all from left to right. You need the derivative of e to a power is e to that same power. You need the chain rule. You're going to need the quotient rule, along with a product rule. Oh my gosh. You need the derivative of sine is cosine. The derivative of tangent is secant squared. The derivative of inverse sine is 1 over the square root of 1 minus x squared. You know the derivative of a sum of functions is the sum of the derivative of those functions. The derivative of natural log is 1 over the input. And the derivative of secant x is secant x tangent x. Good luck. I am not doing this one on a computer screen. I just don't think I have enough room. I dare you to do this and show me your answer.